Good afternoon, everyone. Thank you for braving the elements to come and listen to us. So I guess from where I sit, the point where I normally would like to start a discussion around genetics is really around what are we selecting for, what drives profit in your businesses, and how good a job are we doing of aligning the things that drive profitability in your business with what you're doing when you're trying to select the best bulls or the best rams to take home to use. So I guess we're all aware that the things that influence profitability in our businesses really come back to productivity, price per kilogram, and cost of production. So how do we go aligning what we can select for when we're thinking about genetics with each of those sort of categories? So I guess within your productivity aspects, we're talking about weight, yield, reproductive capacity, that sort of thing. For traits that influence price, things like intramuscular fat, cost of production, mature cow size, net feed intake, disease and parasite resistance, that sort of thing. So I guess the most important thing for you as producers to think about, what's our breeding objective? What is it that we're actually selecting for? How does that link through to how we make improve our profitability? It does continue to amaze me how much we fail to join the dots between that. What is it that drives profitability in my business, and what am I doing? What am I looking at when I go to choose the next lot of bulls or rams that I need to take home to use in my business? And that's going to vary depending on which part of the industry you're in. Obviously, we've got a bit of a mixed group here today. So, if you're northern beef producers, Bos Indicus type cattle, maybe the biggest profit driver you could be selecting for is improved reproductive rates. Southern beef producers, if you've already got good reproductive rates, good growth rates, maybe it's the traits that influence price per kilogram, eating quality traits that are going to have a bigger impact on profitability for you. Or if you're running a meat sheep enterprise, number of lambs that hit the ground, how heavy they are, or through to the merino enterprises, getting more complex as we have to start bringing in more traits, thinking about how wool traits influence profitability and so on. So really important to think through what drives profit in our business, how do we develop a breeding objective to match that, and then how do we start achieving that on the ground. So the next bit I think is worth talking through is, what is it that actually drives rate of genetic progress? So we know from a genetics perspective, the things that influence how fast we're driving change in our businesses really comes back to selection intensity. So what proportion of animals are we retaining to keep in our breeding program? How much better are they than the average, I guess? Accuracy of selection. So how good a job are we actually doing of choosing which ones are the best? How often are we making the right selection decision? Generation interval, how quickly are we getting new genes coming into our business to drive change, and the amount of variation out there in the population that we're looking at. So I guess as breeders, your job is to really think about the selection intensity bit. Which ones are we keeping to breed from? And the generation bit, generation interval piece. How quickly am I bringing new genes in to drive change in the business? From an MLA perspective, most of what we focus on from the livestock genetics perspective is really about how do we develop better tools to improve your accuracy of selection. Tools that mean you're making the right selection decision more frequently. So I guess these days we're looking at developing a number of different types of products, or products in different categories, to assist people with that. So we've still, our gold standard, our main focus is still on estimated breeding values for driving genetic progress in stud industry, for people to use for better ram and bull selection, still giving us that really high accuracy way of selecting across a broader range of traits as we possibly can. So that's still central to what we're doing. But we're starting to see a couple of other categories or types of product develop for other reasons. So I guess the second category is genomic breeding values that you can start using to improve the accuracy of selection as a mob-based tool as opposed to an individual animal selection tool. So our breed plan EBVs or our sheep genetics ASBVs that we can see on the pens over here behind us, they're still focused on how do we choose with confidence the best sire or bull or ram to take home for our breeding program. How do we start thinking about how do we improve the accuracy of selection at a mob level? So out of our replacement heifers, which ones are the ones that are best suited to go back into the breeding program? Which ones do we drop out? And the third category is sort of a benchmarking type of a product. So we've already got things like flock profile for merinos in place, and through work that we've been doing with Ben and others from UQ in the Northern Fertility Project, looking at an equivalent for northern beef industry for using as a herd profile tool to say, where is your business sitting now? Where are we starting from? Once we know what our starting point is, how does that then help us tie all of these different products together and say, we know what our starting point is. We're now in a better position to select the bulls or the rams that continue to push our business in the right direction much more clearly. And once we've got that working for us, we now also know how do we start spending a bit more time thinking about the accuracy of selection from a replacement perspective as well. So I guess all of that really ties together into, what are we trying to do? It's about how do we set what our breeding objective is so we know what we're trying to achieve, how that links through to profitability, using a benchmarking product to say, where am I starting from now? Then that gives rise to how do we more accurately select the replacement bulls or rams to suit our breeding operation, and a way also of identifying which are the best replacements for us to keep. So we've already seen examples of some of these sorts of products out in the marketplace. So if you have a look down the end there at the pen of Angus heifers, we've got both EBVs out of the system that's based on breed plan. Angus used call that taste, but the breed plan system sits underneath that. So we've already got the breeding values available for those animals, so you can select individuals with a high degree of confidence. But we've also got down there the Heifer Select products that Angus put out into the marketplace for helping with commercial heifer replacement tests. To continue building on that sort of idea and filling other gaps in the marketplace, we've been doing other work with Ben and the University of Queensland to look at how do we do similar things in the north and develop similar products for tropical cattle breeding context. So I might just pause there for a second and hand over to Ben to give you a little bit more detail about what's been happening in that space.
Okay, thank you, Hamish, and thank you all for sitting there through this somewhat inclement weather. So what I thought I'd do this afternoon is take you through our Northern Genomics project that we've just completed and the tools that have come out of that you can use to select for improved fertility in your herds. So why fertility? We did some work with Ian McLean from Bush Agribusiness to work out which of the traits are really influencing, which of the traits are really key for profitability in northern beef enterprises. And as a result of doing that work, what really came up was fertility. And the work that Ian McLean did demonstrated that with just a couple of % improvement in pregnancy rates could have a really quite large impact on gross margin, up to $40,000 depending on the size of the operation and so on. So it is a really key trait to target. The problem with fertility though is it's a difficult trait to select for. It's a hard trait to record, particularly under very extensive northern conditions. So how do you go about improving fertility? And luckily we have this new tool, DNA markers or genomics. That might be a tool that we can point at this problem. But how do you actually do that? It's quite challenging to improve a trait like fertility, partly because there's not just one gene that affects fertility. There's not just one gene that if the cows have that gene, they're going to be pregnant. If they don't, they're not going to be pregnant. There's actually thousands of genes across the cattle genome. They all have a small effect on fertility, and it's the sum across all those genes that gives you the differences in fertility that you see in your animals. Luckily, quite a few years ago now, this bit of technology came along. This is a SNP array, or a DNA marker array, or a SNP chip. If you take a tail hair or an ear punch from your animals and send it to the lab, Neogen or Weatherby's or Zoetis, what they do is they run the DNA from your tail hair or ear punch across this little glass slide. And this lovely bit of technology, it takes a snapshot through the genome of your animals, 50,000 DNA markers. So when you do that, you get back those DNA markers. It's A, C, T's and G's, because that's the genetic code. What we want to do is link that up to fertility. Use that to track the fertility genes. What you need to do that, though, is a large number of cows and heifers that have really good fertility records and also have that DNA marker information. If you have that, you can come up with a DNA marker test for fertility. So that's what we endeavoured to do in the Northern Genomics project. We tracked 30,000 heifers, tracked their fertility. We also DNA marker genotyped them on those SNP chips, and then we put that data together to come up with DNA marker predictions for fertility. It was a very large data set. When you do that, there's about 2 billion records that you have to crunch to get those predictions. And you need that huge amount of data, huge number of records, because the effects of each of those genes is quite small. So you need big data sets. To describe in a bit more detail what the fertility records we took were, for each of those 30,000 heifers, and these heifers were in 54 herds around the north. For each one of those heifers, we took an ultrasound scan at about 600 days of age to see if they were cycling or not. So we had people going out and actually ultrasound scanning all these 30,000 heifers. And that cycling or not, we call that trait heifer puberty, that's actually a really nice fertility trait. It has a fair bit of genetic control. The variation in that trait is about 20% controlled by the genetics. It is also a pretty good predictor of lifetime number of calves a cow or a heifer will have over its lifetime. So that was our first fertility trait. The second one was, would the cow get pregnant or not while she was lactating? So the trait was actually pregnant or not 4 months after calving. So a rebreed trait. And as I'm sure you know, in the north, that is a hard thing to do. So we're looking for those cows that could do that rebreed. But also to get the genetic markers, you had to have the cows that could do it and the cows that couldn't. So they were our fertility traits. The other traits we had were weight at about the 600 days, body condition score, temperament. We had docility scores on some of the animals, and we also had tick scores, so tick resistance, and buffalo fly lesion scores, so parasites. So after doing all that work, took 5 years or so, collecting all that data, we can now predict reasonably accurately the genetic value if you just have a DNA marker profile. If you get your animals tested on one of those SNP arrays, we can give you back genomic breeding values for heifer puberty, for P4M, whether they're pregnant or not 4 months after calving, weight, parasites, and temperament. And you can use that, the best way to use it, there's two things you can do. One is to select out teams of bulls that are going to have a good genetic value for those traits. The other way to use it is to cull the heifers that are never going to do the job for you, are never going to be fertile. So those genomic breeding values, the other thing I should say is because those 30,000 heifers we followed through, they're all kinds of different breeds that are used in the north, multi-breeds, composites, crossbreeds. And we did that deliberately so that these DNA marker tests would be useful for any breed, crossbred or composite. I can't say it's useful for every single breed, but for most of the breeds represented in the north, we did have pretty good coverage, and the composites as well. So now, if you're interested in using this type of tool to select out teams of bulls or cull the heifers that are never going to be fertile, to improve fertility in your herd, there is an information sheet just over there under that orange folder, and on that sheet it has the contact details. The person to contact is Elsie Dodd, and her number and email's on that. So what you have to do is give her a call or an email. She'll set you up with either packs that you can take tail hairs and put them into, or ear punch kits and so on, and then they just get sent to the lab. And Elsie will coordinate that, and then when the lab results come back to me actually, I'll crunch those numbers and give you back the genomic breeding values so that you can use them for selection. So if you're interested in that, please take Elsie's details. The other thing you can do is benchmark where your herd is in terms of genetic merit. So the way this works, if you just take a sample of, a random sample of 50 animals, 50 tail hairs or 50 ear punches, send them away to the lab, we'll run the genomic breeding values, and we can tell from that where your herd sits relative to the other herds, all the other herds that we've done. So for example, are your animals really good for heifer puberty, or are they in the bottom 20% and so on? You can really benchmark where your animals sit. And that, we think at least, is useful because you can see in a quick snapshot where your herd sits and say, for example, oh, I need to improve fertility, I need to improve growth rates, and so on. So yeah, if you're interested in that, please have a look at that. Just before I finish, that technology relies on sending your samples away to the lab, which is fine, works well. There are actually about, I think it's 1,500 cattle going through these labs in Australia every week to get genomic breeding values. That's not just beef, that's dairy as well and so on. But huge numbers are going through. But wouldn't it be nice if you could get those genomic breeding values on your farm? So instead of having to send it away, you can just get it back crush side. So that's what we're trying to develop. And that's moving to a different technology, which is actually a mini genome sequencer, drone, which can read off the sequence of your animals and give you back genomic breeding values in the crush. I have to say we're not quite there yet. The person doing this project is Harry Lamb. Not quite sure where he is. Oh, he's over there. Yep. So Harry's going to come back in a moment, and he's actually got part of the gear set up there so you can see what it will look like in the future. We've done a few on-farm tests, or Harry does, so it's getting closer. But in the future, we think this is the way the technology could go. So I'll pull up there and hand it back to Hamish, just in time for the drone.
We should really have timed things better around the drone over there, shouldn't we? But anyhow, nothing wrong with a bit of competition. So Ben started outlining there not just the things that are currently available, but also a few things that are coming up. So I thought probably worth just quickly talking about what comes next as well. So through the National Livestock Genetics Consortium, the current priorities that we've been looking at for further research really relates to carbon neutrality and sustainability traits, further sustainability traits around animal welfare and so on, as well as cost and speed of genotyping. So we've got further projects coming along in that space. But I think it's important for us to consider what is it that our consumers will be demanding of us over the next 10, 20 years, and that really does shape a lot of the ongoing research that we're doing. So at the moment we do have quite a bit of work that's overlaying over the top of the existing reference population sort of projects that we've got at the moment, things like Southern Multi-Breed Project, looking at the temperate breeds of cattle, Repronomics Project, looking at the tropical breeds of cattle, overlay projects that add on to that, things like capturing methane data. So we've got a number of projects both in beef and sheep at the moment, capturing methane data, so over time we can start developing breeding values for people to start looking at how do we better achieve carbon neutrality targets by reducing the methane production per animal as well, at the same time as improving the efficiency of our production systems. So the piece of machinery sitting behind me there, that's an example of one of the green feed units that are being used to collect methane measurements from cattle, both temperate and tropical cattle, for example. Other work being done in things like immune competence and other welfare-related traits. So on that front, I guess if you are interested in more information about the carbon neutrality work, don't forget to see our colleagues inside at the CN30 stand. Other things relating to consumers, obviously, the projects I was mentioning, we are doing a lot of work through those projects to capture eating quality outcomes, both intramuscular fat and other lab-based measurements for things that influence consumers' perceptions, but also sensory work to look at what consumers tell us in addition to what we can measure in the lab. So if you're interested to see some of the variation that we're coming up with in some of those projects, the MSA hub inside has got samples out of both the sheep resource block project and out of the Southern Multi-Breed Project for beef, to show you some of the variation that we're coming up with, animals that have been run under the same conditions throughout their life, of different breeds, different genetic merit, so you can see the sort of ranges that we're seeing phenotypically for some of those traits. So as an example, the samples that I've got in there from the sheep resource block project, there's intramuscular fat measurements ranging from about 2.4% through to 8%. So significant range in what consumers will think of products at that range. Anything that falls under 4% in sheep meat doesn't get particularly well rated by consumers. And the other one I think to keep in mind, Bred Well Fed Well has been one of our main adoption workshops that we've been running in the genetic space. That has been going under a bit of a renewal, revamp at the moment. If you want to see where that's up to, it is at the stage now of that revamp hitting the pilot stage. There was a pilot down in South Australia last week or the week before, looking to do some in Queensland shortly. So if you're interested in finding out more about how to use genetics, the guys on the adoption stand inside will have a little bit more information about some of the work that's being done in that space.